so much for joining with us today. Today is the last episode workshop we have in Bootcamp series. Today, our focus is integrate deep learning models into microservices applications. So for the past, we cover some sessions about containerizing. The first session, containerizing and deploying simple websites. And the second episode, it was explore operators and simplify app deployment. And the third episode was continuous integration and deployment using Tecton pipelines. Today, we have a different sessions, is more related to data and AI. We're going to be more focused talking about data and AI, and we will also show you how simply you can deploy your applications using Red Hat OpenShift. So my name is Muwaffaq. I am a developer advocate in KSA, and I have with me my colleagues, Kareem. He's also developer advocate from Egypt. So before we start, I would like to ask all of you to navigate you to Crocat's platform and how to interface with it. Basically, if you can see on the left corner what it says "Build Smart on Kubernetes Bootcamp," you can click on that, and when you click on that, you will see all the 4 sessions. And you can, if you missed session 1 or 2 or 3, you can go ahead and watch the reply, and also you can get access to the educational resources into each session. The green button, which is down, which is create free IBM Cloud accounts, which is required. We would like to ask you, please, to create free IBM Cloud accounts. Very, very required, because we need to use OpenShift clusters. And in order to use OpenShift clusters, you need to have IBM ID to access to it. On the right corner, you have IBM Developer. You can follow us on Crowcast, and there's also the poll questions. We have set up some poll question for you, so please answer the questions. And we get the chat. You can write it. Yeah, as you can see, the Build Smart and Kubernetes, you can see all the 3 sessions. If you missed any one of them, you can go into it and see the sessions you missed. So let's get started. First of all, log in and set up for IBM Cloud. You need to set up IBM ID. Very simple. You just need to put your first, last name and put your email ID, and then you just need to verify your emails, and boom, done. And then for the tutorials and quizzes, I'm going to walk you through it. Tutorials, we have quizzes if you want to get the certificate, which is required for you to finish all the 4 sessions and to do the quiz for all the 4 sessions. So you can't just do the sessions without without watching the reply for all the 4 sessions. You need to see all the sessions. You need to study all the sessions so you can do well in the quiz. So when you do well, the passing score is basically, I think, 70% to pass to get the certificate. And also we have the survey link. We will share it with you later. And we have the OpenShift clusters, which is 24 hours only from now. You can access to OpenShift cluster. You can play with it as you like, but you will only have 24 hours to access to it. You just need to, the key is basically OS Lab. And let me walk you through the clusters. Basically, when you click on the OpenShift cluster, the last URL, you will see this pops up interface. So basically, you need to put your IBM ID, which is you are required to register with IBM first. And then second is to access to the clusters. You need to put your IBM ID and put the key. And that's how you can access to the clusters. And then you will see this, congratulations. And then you can basically, number 2, log into the IBM cloud. You click on that, and it will send you to IBM cloud dashboard interface. And as you can see, the clusters has been provisioned for you, and it's ready for you to use. And then once you click on the clusters, it will send you back to IBM interface for OpenShift clusters, and this is how it looks like. And then you just need to click on the right corner, click on the to navigate to the web consoles, and that's the OpenShift interface web consoles. We need to access to the OpenShift interface web consoles. That's most of the hands-on. We are going to work with the web console today. Also, we're going to be working with the CLI. So Karim, he will walk you through that. So today, the agenda basically, we're going to talk a little bit about data science. We're going to talk a little bit about basic concepts and give some methodology. And then we're going to be talking about computer visions and basic concepts about computer visions. And we'll talk a little bit about IBM Watson's in terms of AI and data. And we will explore the use case together. And then the live coding sessions will be handed over to Karim. And we will have a really fun demo with the using Python TensorFlow app. So stay tuned. All right, so first of all, let's a little bit talk about the methodology workflow in the high levels of any process of AI applications. As a developers, as we are developers, that's how we can, that's the process, the workflow we start with. So the workflow always starts with a start point, right? So you start the point, and then the next, what is it? The next is basically business understanding. You need to understand what is, what's the business goal? What are you trying to achieve? And this is business understanding. Basically, the team, business analytics teams and business intelligence teams are responsible in this and in charge of understanding the business. And this is the team who understand the business of the data they want to collect. What's the target they want to achieve from the data? So business analytics teams and business intelligence teams have to do this process. They have to do this process. But data scientists, they will do the whole workflow. So first of all, you need to understand the business. What are you trying to achieve? What type of data you need to collect? And why do you want to build this app? And then the second comes to data processing. Data processing, it comes to the challenge of collecting the data, which is very challenging sometimes to collect the data. You need to collect the data. And once you collect the data, which, you know, you can't really find the data, it's clean for you and it's ready for you to use. It's impossible. You have to do some analysis, you have to do some cleaning, and that comes to, you know, to the data analytics teams. They have to do this. They have to clean the data the way they want it. They have to analyze the data. And once they analyze the data, the process starts to build the models. Once you have a clean data, you collect the data, you clean the data, and then second is to build the models. Now you feed the machine learning to build the models. And you write some codes, algorithms for any to train the machine learning, to build the models. And then once you build the models, it comes to train the models to the machine learning, train the data inside the machine. And then once you train the data, it comes to test the models. And then test the models to see if the models is basically is what you do some evaluations. If the models is what you're expecting, is it really the goal that you wanted, or is not, or it's not accurate? If it's not accurate, it goes back to data processing again. It goes back to the build the model again to, you know, to simplify the algorithms and to train again. And then finally, if the evaluation is accurate and it's the result it's good, then it comes to, you reach to the business outcomes. And then finally, deploy the app on clouds or on top of OpenShift cloud natives. So we are going to, yeah, this is basically the the whole scenario, the story of the application that we created using AI, object detection applications we have for you today. So this is the whole story behind it. So now we're actually going to show you how you can deploy it. We're not going to show you all the process. We're just going to show you how you can deploy the app. The app is ready and it has been built, and we're going to show you just how to use OpenShift and so on. And finally is the maintenance, to maintain your app. So what type of the data basically we have for today? We have like speech, which is a part of communications, and we also have a text, right, which is also part of communications. We have also images, which is a part of computer visions, and also we have a business data sets. Business data sets is basically is just a history of the company customers or history of patients at the hospitals. Business data sets, I would like to focus on that. Business data sets is basically, in today in the market, a lot of data scientists and analytics, they do their jobs to make insights of the business data sets, because they have a history of, let's say, patients at the hospital for the last 6 years. So it's a huge amount of data. So the hospitals spend millions on this data, trying to make sense of the data and understand the patient flow or whatever business they're trying to achieve outcomes of the data. So, and also we have a text which is part of NLP, natural language processing, and we have computer visions, which is AI in general, two different areas. The NLP and the computer visions. This is the most famous in research and the most famous in development in terms of AI applications. So today we're going to be more focusing on image processing and classification object detections models. We'll talk about some of the concepts in computer visions. Let's move on. So this is some of the Watson services we have in terms of visions, visual recognition, in terms of speech, text-to-speech or speech-to-text. And also in terms of NLP, we have Watson assistants to build conversations AI platforms. We call it chatbot. And also we have virtual agents, which is a part of voice-to-voice. You can speak voice-to-voice. And also, we have also Watson Discovery, which is a machine engine powered by machine learning. IBM machine engine powered by machine learning. Simply, you just need to feed these machines, and then you can train your data. And yeah, we have natural language understanding. And I would like to give you just overview about what are the IBM softwares in terms of data and AI. So computer visions, as you can see right now, basically we use our eyes to see and to understand. Sometimes we don't need to speak or to do texting. We can look and we can process things using our brain, and that's what they call it, deep learning. So that's the main concepts. We can see things. We can look at the images. The images has the features. It has the colors. So we can understand it because it has a contents in it, and we can process this. We can understand this is represent to something. So computer visions, the first photographs made in 1860, and that's the history of the computer visions when starting research. So this is basically what do we see? We see pictures. That it has some colors, it has some contents, it has some features inside. So we can understand the features. Well, this picture is represent to flower. This picture is a flower. But the machine cannot really understand this picture. The machine just only can see a gray pixels. The machine, that's the machine what they can see, comparing to human eye vision. Human visions. So this is what the computer can see. Just only can see numbers, which is, those numbers are represent to colors, to contents, to features. So when we train the machines for images, that it has a colors, and those images, so the machine can understand the colors and the contents, because in the algorithms such as TensorFlow, it can understand that because it has the colors and contents. So the machine only can see numbers, which is represent to pixels, and to colors and contents and features. So deep learning, CNN, convolutional neural network, which is one of the famous class of deep learning. So if comparing to the computer visions and AI visions, when we look at the pictures for any type of animals, we can recognize this. Oh, this is a cat, or this is a dog, and it's the same concepts in the deep learning. Deep learning basically it has the input layers, and we have the hidden layers, which is the filtering and the making decisions layers and the hidden layers, and then finally is the outputs, which is the recognitions or the decisions of yes or no, and so on. And that's basically how the process can start. I'm not sure. Yeah, this is basically the TensorFlow. When we feed the pictures of cat, it starts in the input layers, and then we have the hidden layers, training the machines on these pictures. Not just only one picture, we give more pictures to the cat, and then finally the output layers making decision yes or no, this is a cat or not. And using the TensorFlow, which is for data flow graphs to build models, and it allows developers to create large-scale neural networks and many layers. Object detections basically is open to us the ability to recognize more details in the images. So object detections, you can get more details in one single image. So that's why we call it object detections. But classification is just making a decision of yes or no. So this is an examples of AI use case in object detections. Today we see in so many industries. So today we'll focus on transportation industry. So this is the video. As you can see, we are using the camera to watch in distance to make object detections for who's speeding, or who's maybe cutting the line on the highway. So AI, you can see the camera can see in a distance, but comparing to our eye visions, we can't really see in distance compared to our eye visions. But the computer visions, digital cameras can see in a distance, and that's the benefits. AI use cases, applications like this applications can be used in so many industries, not just only transportation, but also can be used in healthcare industries, for scanning cancers or whatever. So yeah, it can be used in any other different industries. So moving to IBM and Red Hat, basically. So why containers? Containers are basically changing the economics of delivery today. And most enterprises now are moving to containerize their application using the OpenShift. And now containers allow developers or operation teams to package up their applications with all of the parts it needs, each such as libraries and dependencies and so on. So Red Hat OpenShift is basically just a platform for deployment, cloud-native microservice-based applications. It can be hosted locally or on IBM Cloud, hybrid clouds, private clouds, and so on. Built on top of Kubernetes and deploy on Red Hat Enterprise Linux Core OS. Overview about Red Hat. Red Hat is, of course, definitely is security and isolations, integrations, operational tools, easy to use, a platform that supports so many open source technology and native open source experience. extend apps with IBM Cloud Services. You also can extend apps with IBM Cloud Services. So today, to explore the use case architect about the app, and Kareem, he will share the code with you. So the app, it has been already developed with using Python's TensorFlow, and it has been and we created the Docker file for the app, and it has been published on a Docker Hub publicly, and it's very accessible to anyone to use. And yeah, so the app, Kareem will walk you through it and explain the app more to you. So as you can see, the user interface with the app and the app, this is the architecture of the app and what are the algorithms and open source APIs has been used, which is TensorFlow, and developed with programming languages Pythons. And the Docker is to build the image for the app, so you can have the free to ship it into any computer machines or any environment to run it. So this is how it looks like, the app. Today in the hands-on tutorials, we're going to take the whole thing, the endpoints, the back end and the front end, the REST APIs. We're going to push it into containers, which is running on top of IBM Cloud. So you will see how Kareem, he will walk us through how to do this using the web console and also using the CLI, command line interface. So I would like to ask you again, please, to log in and sign for IBM Cloud, because if you want to follow with us now, you need to have an IBM Cloud ID in order to access to the OpenShift clusters. So as I explained before, you need to put the ID, put the password, and then you will receive an email, verify the emails, and then get the emails into the OpenShift clusters and put the key OS Lab. Please do that. And let me navigate you through the tutorial and quizzes. So to explain more about the tutorial and quizzes. Just put this down. Okay. So I'm going to share the resources with you. So basically, in the tutorial and quizzes, you need also to use the same IBM ID in order to access to the tutorial and quizzes. If you use any other IDs, you're not going to get the certificate. So you have to use the IBM ID. So let's use the IBM ID. So let me put my wait. Cool. Okay. I hope not forget the password. Oh no. Okay, let me access to my IBM ID. Oops. No. Come on, don't show me error. Okay. Okay, so now, as you can see, now we access to the tutorials and the educational resources we have put into this bootcamp. So, you know, as you can see that we have Start Lab 1, Start Lab 2, Start Lab 3, Start Lab 4. So all the 4 labs, you know, you can access them. Once you click on the lab, it will send you to the education, to the resources, to the documents. So you can follow the hands-on and you can do the labs. For example, today we have AI integration max model deployment. If you click on the Start Lab, it will send you to the document. for this lab, which is provided in a PDF extension. Okay, that's the hands-on that today we're going to follow with Kareem. Okay, so basically, let me just walk you through, giving some summarizing. So the first lab, introduction to Red Hat OpenShift using Go. What you will learn in the first sessions in this episode, you will learn how to deploy Go applications and how to use OpenShift web consoles and how to explore the Go websites and how to access the website. And that's what you're going to learn. The second one, which is an introduction to operators on Red Hat OpenShift, which is what you will learn is basically is to deploy the IBM Cloud operators from Operator Hubs. Operator Hubs, which is a marketplace for open source projects. You can use Operator Hub to access to cloud operators, and also you can what you will learn you will learn how to configure operators to work with IBM Cloud, and also how to create Cloud-Int service. Cloud-Int's like it's like a database storage to store tables inside it. It's like it's like a database storage, and you will learn how to create a Cloud-Int service in the IBM Cloud, and then you will learn how to deploy the backend and the front for the patient health app. So in the second labs, we have patient health app, which is very very nice app. You can look at the resources, and so you will under. So go ahead and do some reading about that. And then third lab is basically introduction to Red Hat OpenShift pipelines. In this lab, you will learn how to you will learn about token concepts. You will install OpenShift pipelines and deploy simple applications, and create pipelines and trigger your pipelines. And today, we will just see how we can deploy object detections, microservices app using the web console and CLI. And congratulations, you are done. Now let me send you, after you finish all this, session lab 1 and lab 2, 3, 4, now you need to test your knowledge. So the quiz, the passing score is 70%. You need to put your first name, last name, and the IBM ID. Please put the IBM ID. And then in the first lab, you will have a multiple question. You need to answer that. And second labs, you have a multiple question. You need to answer that. And third lab, and so on. And for now, once you finish all the quiz, just hit submit. And then if you pass, you will receive the certificate by email. Okay, I hope that clear. I'm gonna look at the chat, but I can't. Oh my gosh. Okay, so yeah, that's what I just want to mention. And this is how you can create it, your IBM ID. Just put your email, your password, and just verify your emails, and you're done. And this is where you can put the emails, put the key, OS lab, and put your email ID, IBM email ID, hit agree, and submit. Remember, this is just only 24 hours access from now, from this time. Okay. Get back to the slides. Okay, so let's get started. The hands-on, this is the resources for the hands-on. I'm going to share the resources with you on the chat. So back to you, Kareem. You can start. Over to you.
Thanks, Muaffaq. Thank you very much. So welcome, guys, gals. So let's get started. I'm going to share my screen. And okay. Great. So again, this is the main page for the Build Smart on Kubernetes series. So I'll paste that in the channel. And if we scroll down here, we're on lab 4. We're on session 4. So this is the 4th lab. Once you're done this and you go do the other labs, then you can take the exam, the quiz, and get a certificate, a badge, like Muafak said. So we're doing the 4th lab here, max deployment. So if we click on this, it'll open up this PDF. Okay, so just very, very quickly, we know that the topic talks about max model deployment. And basically what max is part of IBM's Center for Open Source Data and AI Technologies. So this is an initiative by IBM for open source models and data assets and so forth. So it's called the Center for Open Source Data and AI Technologies. If we scroll down, we'll see that the projects, one of them is Model Asset Exchange. This is a place where the world, the global community can actually, get access to open sourced models. And you also have data assets. So the data assets are, to run AI, you need data sets, lots of data. You need models that you train. So if you click on the Model Asset Exchange, this is what we're talking about today, the Model Asset Exchange. It's a list of many, many models. You can view them, lots and lots of models. Some are trainable, some are deployable. And what we're looking at today is object detection. So today we're focused on an object detection example. So we want to see object detection. So where is that? If we look at models here, we should see object detector. So this is one of them. And where are these housed? So where's the code? Where is everything? How it's been done so that you can run this stuff locally on your own environment. It's been all published on Docker Hub. So if we go to Docker Hub, which I had here, Docker Hub. Been doing this. In Docker Hub, we actually published the code date. We have a code date like group or org. And here is where we can look for object detection. Codedate max object detector. This Docker Hub is where you store images. So containers are really running instances of an image. So you have here what are called Docker images. So if you want to run it locally and you have Docker installed, you can just do Docker pull codedate / max object detector, and you can run this this program, this app. And what is this app? This app looks like this. It's going to be an app that you upload an image or use a web camera, and it will detect. It will detect, yeah, this is a person and this is a teddy bear, for example. And it's all running locally on your machine. And if you want to run it on OpenShift, it's just as easy as running it locally on Docker Hub. So that's what we're trying to do today. In terms of what's an image, it's basically, if we look on the right-hand side, we'll see there's a GitHub repo for this example. So if we click on the GitHub repo, this is now where, if we look at core, we'll see that the model is using TensorFlow, and it's pretty fancy, and that's what's been open sourced. So all that is bundled up in a Docker image that we deploy on OpenShift or locally on our computer. Under the hood, what is it? It's an app. This is what the app looks like. It's a Python web app. You upload an image, and then TensorFlow machine learning runs. And this would be on your computer if you're running it using Docker, or on OpenShift if If you have a cluster, an OpenShift cluster, it would run, and in 1 second or so, it would detect from the image, this is a person, this is a cat, for example, and so on. So that's what we're doing today. So again, this is part of the Codate initiative, open source. One of the main projects is the Model Asset Exchange. And where do you go and find all this stuff? Inside Docker Hub. Everything's published in Docker Hub, and that's where the community can use it. So you don't have to worry about the code. You can just get an image. So if you look here for Max Object Detector, you can get a ready-to-go image. So in like 2 seconds, you can have you can be running object detection just by doing a Docker pull. After you have the Docker image, you can get fancy and look inside the TensorFlow and so on, or you can go to GitHub and download the code and customize the models if you want, rebuild the image and test it. So that's kind of the open source way of exchanging models. So that's what Max is. So let's look at our example here. So what we're doing here is we got to make sure, like Moafek said, that we created a cluster. So where is that again? So based on the link, this is the link to get your free cluster. You put in your ID, you put in your IBM ID that you just created, and the lab key is OSLab. And I think that was sent before. What's a little bit new here is just to get it going, you're going to get an email. So once you do this, you're going to get an email that looks like this. And in the email, you just have to click Join Now. Once you do that, and this just changed recently, once you do Join Now, then you should be able to see your cluster. Where is the cluster? It's on IBM Cloud. So you run this, you click Join from your email, then you go to cloud.ibm. Cloud.ibm is our public cloud. And here's where we have OpenShift and all the products. So here you should have on the top right-hand side an account called Advocacy. That's a temporary account we created for you. So just make sure you select that. And when you select that, when you go to the left-hand side and click on OpenShift, you should see your cluster, just like here. You should see a list that looks like this, and you should see your cluster. Then you click on that cluster. Once you click on that cluster, then you get into OpenShift. This is an OpenShift cluster. So this is what OpenShift looks like, that the cluster that's created for you. Of course, this is just schematics. What you want is the administration, the web console. So you click up on top, OpenShift web console here, and that now you're in OpenShift. This will open up what we call the OpenShift web console. Okay, so you want to make sure that you get to the screen. Now you're in OpenShift, and the rest is very easy. So this is when it's the first time, you just have to make sure you create the cluster is created for you, and you have to get into the web console here. So that's really the prereq to just make sure you have that. The other part of that here is the dashboard. This is what we just showed you. And you click the web console. And now we're in OpenShift. So you should be in this area. Now we want to deploy the app. So we want to deploy this app. So how do you deploy the app? So you have what are called perspectives. So if we go back to the admin console, the web console, the OpenShift web console, on the left, it's really easy. You have two kind of views. One is an administrator, which we're not, we're developers, you know what I mean? Like AI developers. So we can go to the developer perspective, okay? And you have the concept of what are called projects. Let me make a project first. So I'll go back as administrator, and I'll make like a project, which is where I can group my stuff, where I can put all my work in one area. So under projects here, I can create a project and call it Max Detection, say 002, for example. That's just a name to kind of group everything in OpenShift. So, and I click projects as an administrator, and now I have a project. I go back to the developer. I make sure I click on topology, and up on here where it says project, I make sure I'm in the project that I just created. You know what I mean? And these are the different ways of deploying something to OpenShift. And the easiest one is using a container image over here. Container image means just give me the name in Docker Hub, or there's another image registry called Quay. Just give me the name of the project. So here in Docker Hub, when I do a Docker pull, I'm going to say codedate, which is the name of the organization, / max object detector. This is all I need to deploy. I just put that one value, press enter, wait a few seconds, and the app is deployed and running. Don't have to do anything else. So how is that done? Using what's called container image. So let's go back to the document. And here, it's using container image. So this is now where we go and we click container image. And here we put the image name that I just copied, which is this name, codedate / max object detector, because it goes and it checks, it validated. It actually goes to Docker Hub and other public image registries like Quay and Docker Hub. And when it finds it, it says validated. So now it's able to find it. You don't even have to put in the URL. You just put the name of it and you get a green check mark. You don't have to do anything else. These are just default names, not really important. But since this is machine learning and there is some processing, TensorFlow is pretty heavy. So we want to make this image, when it runs as a container, have more memory. We need, like, say, 2 gigabytes of memory. How do we do that? Well, that's the next step. Over here, we put in the name of it. And if we scroll down, we just specify the resource limit to say we want it to be 2 gigabytes request and 2 gigabytes limit. We're specifying a min and max for the amount of memory that we want running. What else do we want to do? Scaling. How many copies, for high availability? When I deploy this on OpenShift, because it's ready for production, I can say I want two instances of this app running in 2 different areas. So if something happens to one, the other one runs. That's what's called scaling. But we'll keep it as 1. What we do care about is switching the memory to 2 gigabytes because it's more than the default, because this is an AI app. If we scroll up a little bit, there is one setting. It's not really very important. It works without it, but it's in the documentation. Something in the deployment called CORS, cross-origin resource scripting. These are just environment variables. So that's kind of the beauty of OpenShift, that you can put environment variables that get picked up by the image. So let's go and do that. Very, very simple. So over here, all we did is we put the name of the image. It found it. We scroll down, and let me make this bigger. We scroll down, we click on routing. That's nothing. We don't change anything here. We click on deployment. Here is now where we add an environment variables called CORS enable. And this is what's called cross-origin. It's something because the browser on the back end may be different. It's something for developers would know about. But it's in our example, it's not necessary. But just so you know, you could add environment variables here. The next thing is we want resource limits. So all this is, when you deploy an app, you can start now giving it environment variables, give it more CPU, more memory if you want. So here, the memory, I'll just switch that to 2 gigabytes and switch that to 2 gigabytes. That's it. I press create. And it goes ahead and it creates this nice looking topology. So here, if I click on it, this is the app. If I click on it on the right, I'll say container creating. If I click on the logs, this is a container, like a running server, what we call in OpenShift or Kubernetes as pods. So a pod is really a container, 1 or more containers. So we view the logs. and we can see what's happening. If we view the logs here, and this is stuff you don't have to do. It's interesting to see. So containers being created and the log. So it's just going and it's downloading the Docker image, and then it's going to deploy it. So we'll come back to that because I have one that's already done. So we'll come back to max detection 2. We'll go to the other one that I have. I call it max. Oh, it's running. So this one's running anyway. So again, I'll go back to topology. I'll click on here. Now it says running. It used to say container creating. Now it says running. If I click view logs, it should show me some logs that are specific to the container. Yeah, I see TensorFlow. It's running TensorFlow CPU instructions. I see model.python. So now it's running. So now how do I use this? I want to get to the web app. Where's the web app? So all we really did is we just put in the name of the image, specified the minimum and maximum memory, and we deployed it. It took a few seconds, and it says running. And at the very bottom, we get a route, a public internet route. So if we click on that, this is what's called, this is called Swagger. It's a Swagger API. It's a way to test back-end code. But if we want to see the actual app, we just add /app. Yeah, and this one, it takes a few seconds to run it. It takes a few seconds to run it to actually create what are called the ingress endpoints. But once it's done, it will look like that. So this one is already running with a /app. So if we look back at the documentation, so after we do our scaling, our memory, it deploys it. And after it deploys it, we click on that link and we go and look for the URL, the resource, the route, the URL. And once we click on the URL, we're going to get this, which is the Swagger API. And all we do is we add /app. So here you can look at this if you like, but all we have to do here is this step. You just add /app to the URL. Once you add /app, you get this. And what's this? This is the web app. That's the web app that was deployed. And now we can test it. So we can choose an image or use a webcam. So here we can choose an image. And here I have like this image. We can do the simple use case. Submit any image you want. And this is a cat. It's detecting. And it's going to take a few seconds. I picked a pretty big image this time. So it's running maybe a little bit slow. Yeah, it came back. So it's just something with the endpoints. It's a little bit sluggish, I think, because the image was really big, but it came back and it said cat 94.7%. So now we have a full-blown app. It's open sourced. I can change the low-level TensorFlow code if I want, the layers stuff. It has a nice web UI. I can deploy it in 2 seconds using a container image from Docker Hub on OpenShift. And basically, that's the example. We can try some other images, which hopefully are a bit smaller. I didn't actually test these. I should have, but it's just fun to kind of see. I mean, this is open source, so it's not going to be perfect. You know what I mean? But it's basically like a starter, a way to get people into object detection, try things out. I picked really big images, so that's why it's a bit slow. But I have a smaller image that I can test with. But this should come back. You should find, yeah, so great. Elephant, 95%. And this now you can start noticing, well, why didn't it find this elephant? Because maybe the object detection needs a tail for the elephant. And what's that called? We call that threshold. So the threshold means it won't put a box around the elephant unless it's more than 50% sure. And this, it was 87 and 95. Let me lower the threshold. And once I lower it, bang, I get the third elephant. 47. But I also get some errors. It's this elephant here. So of course, it sees them as two elephants. So this is now where you can make advances in the open source Max model and start customizing it to your needs. So that's pretty much it. That's the entire example over here. So you can do it with simpler examples here. And just don't forget to do the lab, to do the quiz. So do all the labs. It'll be really fun. I think you'll learn a lot from them, like Muafak said. Once you're done with the labs, then you can go ahead and take the certificate, and you get a badge from us. So that's it. So let me go try to answer these questions. So let me just stop sharing.
Yeah, there is a question about connecting the REST API backend with the front. They need to put the environment variables as a core enables and give the value to it enable. The true, give the value to it true.
Yeah, I did that. Yeah, that's right. So I did that here. When I deployed it, we set it as true. So the environment variable here, when we deployed, but that's, in our case, that's not essential. So in our case, when you deploy it on, so here, if you put code date and you deploy it in
deployment,
deployment here, you put cores enabled. The only time you need that is if your UI, if the front end is in a different location as the back end, because the browser, if the browser up on top, it's a URL that's different than the API call, then you have basically it thinks that your browser is trying to connect to another server and make a connection. And cores is something implemented by the browsers. It's protection, so that if you open a website to say localhost on your local computer, you have your UI on localhost, but in the code it's going to IBM.com. The browser will prevent that. It'll consider that as a type of cross origin. The origin of the UI is different than the origin of the API. So you're trying to do cross origin resource scripting attack. So it prevents it. So that's why the documentation here encourages us to use cores enable true. And since we're deploying on OpenShift, the UI and the backend are at the same URL. So URL or subdomain works as well. The cores only cares if the top level domain is different. Okay, so back to you, Muafak.
Okay. Yeah, I also I share in the chat the back end and the front end. If you are interested in learning more about the demo, you can access to the GitHub for the back and the front. I just shared it in the chat. Let me go back. How to share my screen? Got it. Okay. Can see my screen, right? Okay. Yeah. To summarize. So again, you guys, if you really want to pass the quiz, it's not going to be easy quiz. The passing score is 70% to pass. You need to cover all the sessions. You need, if you haven't really access to the sessions before, then you need to go back, and as I just show you how you can go to all the labs and start learning about all the educational resources we provided for you. So to summarize, the session 1, we cover about containerizing and deployment a simple web app. Session 2, explore operatives and simplify app deployment. Session 3, continuous integration deployment using token pipelines. And today, integration, deep learning models, TensorFlow into microservices applications, back and front. So, yeah. IBM Developer, this is a useful resources. There are a lot of resources, machine learning, data and AI in different industries. You can go to developer.ibm.com and you can search for any topic you like. And also for Red Hat developers, you can also go to developers.redhat.com if you are interested in containers, Kubernetes and OpenShift technology. You can also find a very amazing resources in both IBM and Red Hat. Also, some learning platforms, learnOpenShift.com, also CognitiveClass.ai is a really great place to learn. And yes, so if you want to get the badge, you need to go to ibm.biz/bsok/skills. I will share that with you. And also you will receive an email after this sessions for all attendees who register. All right, so talking about Code for Code. Code for Code is basically initiatives. Invites developers and problem solvers around the world to build and contribute in open source solutions. And Call for Code is in organizations, and it's a partner with IBM, IBM founded partner, and also Call for Code is a Linux foundations, based on Linux foundations. So we want, if you really participate in Call for Code, you may be gonna win 200K US dollars. And it's a really quite amazing challenge. Last year I participated in Code for Code. It was amazing. I learned a lot. I gained a certificate. So it's really good to join the community and show your skills and make a difference. Make a difference to the world. So in this year, the focus is in 3 different categories. One, it's the clean water, and the zero hangers, and the responsible predictions and consumptions. So if you have a use case or innovations in the 3 different areas, categories, you can go ahead and participate. We also have covered for you educational resources, tutorials, and technical resources covered for Code for Code. If you go for Code for Code 2021, you will see interface, web app, give you all the information detail you need. And also we have Slack channels. You can join the community for Code for Code, and you can form a teams. If you don't have a team, you're just by yourself and you're looking to participate, but you need a team, of course, you can join the Slack channels. You can propose your idea, and you can ask the community to participate with you. You can propose your idea in a Slack. You can form a team in a Slack, and yeah, this is a really good to start with. So we have a Slack channel for you to join the community. Yeah, I'm going to share all the resources with you. Okay. There we go. Now it's time for survey. So we would like to ask you, please, to scan and give us your feedback. That will help us in the future to improve. Please, you can scan using your cell phone right now. It's very simple. Or just, I already shared the URL with you in the chat. Or just use your cell phone and just give your feedbacks. It's really important, really important. And let us know what is the topic or the area that you really want to see in the future. Yeah, and this is my Twitter, LinkedIn, Mawfaq Diaby, and Kareem also Twitter and LinkedIn. I'm not sure. Kareem Dive, yeah, I think so. Kareem Dive. So yeah, follow us if you have any questions. Let us know for sure. Yeah, thank you very much.
Thanks. So I just want to answer one of the questions. Like Srini, you're asking what's the difference if we execute the same model from IBM Coppak for data from the OpenShift cluster. So I guess what you're asking, Srini, is what's the difference between Coppak for data and having models there versus what we just showed you now on OpenShift. So there's a major difference, big difference. So Cloud Pak for Data, for everybody, that's just a product, kind of one of IBM's flagship AI data and AI product, which is called Cloud Pak for Data. That sits on top of OpenShift, which we saw today as OpenShift. So it's something, it's what's called a Cloud Pak that sits on top of OpenShift. But what we showed you today is in OpenShift, just taking an open source, a simple model, not very trained just enough, so that you can test it out and build upon it. But the Cloud Pak for Data uses very, very, very strong industry tested models, which are what are called Watson models. So these models are trained with millions of data points. So the models that are used are much more powerful in Cloud Pak for Data. And in Cloud Pak for Data, you have a lot of automatic machine learning stuff, what's called auto AI, that can auto generate models for you based on your data. It also has stuff to check for bias, if your data is biased or not. So it's a whole suite for AI, enterprise AI solutions, Cloud Pak for Data. What we showed you today was just kind of an open source intro into what you can do is if you want to learn about TensorFlow and you want to run something yourself using the least amount of code. This is basically what we were showing today. So it's very, very different. And IBM's enterprise solution is Cloud Pak for Data. Today it's just an open source example of what can be done in terms of OpenShift. Yeah, and then the last one is in the Mofak. It's in the question and answers. So the third or fourth one by Afiz. Hi, thanks for the insight. Is it possible to validate an object with another object? So maybe you can clarify that and just let us know if you can write a message. And just let us know if you. Yeah.
I will answer the question. I will answer the question after. I will write down the answers. Okay. Yeah, this is all we have for you guys. Please do some survey for us and let us know the feedback. And yeah, thank you so much and have a beautiful day. Thanks.